Here's a vector word problem. Feel free to give it a shot and keep watching to see the solution. Okay, here's how to do it. So a fish is swimming 17 kilometers an hour north. Which direction is north? This way. Okay, so we're swimming 17 kilometers an hour north. And I'm going to call this vector u. You can call this vector anything. What are the components of u going to be? Are we moving at all in the x direction? No, so 0. But we are moving in the y direction. And it's going to be 17. Now, what happens next? It encounters an ocean current, moving at 8 kilometers an hour from the northeast. Which direction is northeast? Okay, so I'll draw a compass here. Oop. Okay. So never eat soggy waffles. Okay, so this is northeast. This is southeast, southwest, northwest. Okay, but it's coming from the northeast. So it's coming from here, but it's pushing on the fish this way. Okay. So this is going to be the ocean current vector, and I'm going to call that vector v. How do we find the components of vector v? Well, I'm going to draw another diagram. Okay, so why did I draw another diagram? To make it easier to find the components, but these are the same vectors. Why are they the same vectors? They're the same vectors because we don't care about the starting point. We only care about the direction that we're moving in, as well as the magnitude. Okay, so to find the components, you need to find both. Let's start by finding the magnitude, because they gave it to us. Okay. Now, what's theta going to be? How many degrees do we need to rotate counterclockwise? Okay, so this is how many degrees? 180 degrees. And then to go from here to here, that's how many degrees? That's another 45 degrees. Okay, so 180 plus 45, that's 225. Okay, now what's the formula to find the components of vector v if you know the magnitude as well as the angle? So it's going to be magnitude times cosine theta, and what else? Magnitude times sine theta. Okay, so let's go ahead and plug these in. So it's going to be 8 times cosine of how many degrees? 225 degrees. Okay, and what else? 8 times sine of 225 degrees. Oops, 225 degrees. Okay. And you can use a calculator for this, but you're going to get approximately negative 5.7 and negative 5.7. Okay, so let's go back to this diagram. What are the components? negative 5.7, negative 5.7. Okay, but the question is asking for what? The velocity relative to the ground. So what vector is that going to be? It's going to be this vector. Okay, and how do we get this vector? I'm going to call it vector W. So this vector plus this vector is equal to this vector. So we can get it by adding vectors u and w. So let's go ahead and do that. Okay. So I'll write it here, vector w is equal to vector u plus vector v. Okay, so let's go ahead and plug these in. So I change u to 0.17 and v to negative 5.7, negative 5.7. And how do we add vectors? So we can add the x components. So what's 0? Okay, 0 plus negative 5.7 is how much? Negative 5.7. And 17 plus negative 5.7. So 11.3. Okay, so let's go ahead and write that here. Perfect. Now, the question is asking for what? The velocity. So what does velocity ask for with this vector? If you see velocity, you need to think about the word magnitude. Okay, so what's the magnitude of this vector? What's the formula for that? It's going to be square root of x component squared plus y component squared. Okay, so you can use a calculator for it, but you're going to get approximately 12.7. Okay, so 12.7 what? 12.7 kilometers per hour. What else do they want us to find? They want us to find the direction and give the answer as a bearing. So when you see the word bearing, they're basically asking you for this angle. So how many degrees do we need to rotate clockwise from north? Okay, so we don't know how to find this angle, but what angle do we know how to find? We can find this angle. And what's the formula for that? It's going to be arctan of y component divided by x component. Do we need to add something at the end? What quadrant are we in? So quadrant 1, 2, 3, 4. Okay, so we're in quadrant 2. And if you're in quadrant 2, you need to add 180 degrees. Same with quadrant 3. And with quadrant 4, you add 360 degrees. If you're in quadrant 1, you don't add anything. But we're going to have to add 180 degrees. And you can use a calculator for this, but you're going to get approximately 116.8 degrees. That's how many degrees we need to rotate counterclockwise. Okay, so if this is 116.8 degrees, How many degrees is this? How much should we subtract from 116.8? We should subtract 90 degrees because that's a right angle, and it's going to be 26.8 degrees. Okay, so if this is 26.8 degrees, how many degrees are in this? Well, this plus this is a full circle. So to get this angle, what should we do with 360 and 26.8? We need to subtract. Okay, so that's going to be 333.2 degrees.